Make sense? So let's say this one is picked as center in the very first iteration, and let's say this one is picked as another center. That's it. So I guess if you see closely, I guess this might be one cluster,
Yes.
might be, and this might be another cluster. Yes? By picking this randomly as a mean, this randomly as a mean. Randomly, let's say these two are here. So this is one cluster, this is another cluster.
वो सिंपली हम दोनों से कंपैरिजन करेंगे जिससे डिस्टेंस कम होगा वो उस पर
Yes. So xj is assigned, xi is assigned label j if it is closest to the jth field. Make sense? Okay. Now you recompute the centroid of this, and the center of this might become here. This is no longer a data point.
Yes.
And you compute the center of this might become here. And now you erase whatever you have done, like you have never done anything so far. Make sense?
You compute again.
And you hope that now you have a better estimate of means. Now you cluster again. In this case, the clusters might look like the following. Maybe this. Maybe this. I don't know. Maybe this. And this. Yes?
Yes.
Now you delete these. Compute new means. Delete the previous grouping. Keep on moving until the mean doesn't change or the assignment doesn't change.
Those.
दोबारा से फिर बस इसके मींस का
हाँ दोबारा जैसे अभी फॉर एग्जांपल मेरे ख्याल में पॉइंट चेंज नहीं हुए
असल में सवाल अगर आपको ग्रुपिंग गिवन है यू कैन फाइंड आउट द मींस अगर आपको मींस गिवन है यू कैन फाइंड आउट द ग्रुपिंग
बट वन इटरेशन हम कर सकते हैं हम रिपीट क्यों करें प्रोसेस बार-बार
बिकॉज़ जो आपने इनिशियल डेटा पॉइंट्स लिए थे ना they were not the actual representatives, at least you should hope so the grouping was erroneous. सही है? So with respect to that grouping, you have to compute the new means because the grouping was erroneous, the means were erroneous. As you move down in the iterations, the error will come down and down. Because you fix one thing, you minimize for the other, you fix that thing, you minimize for the other, and so on. This algorithm highly depends on all the initial data points you pick. In the following way. हो सकता है जब आप converge करें यानी जब आप end result लेके आएं, you come up with this grouping with this one and this grouping with this one. And आप variation total variation compute करें, इसका इसके साथ distance compute करें, इनका सबका इसके साथ distance compute करें, that's the total error of the clustering. Yes? And you may have chosen at the very start a different means, and you may come up with a different kind of grouping with a smaller error. So this algorithm does not guarantee the global minimum. Yes? So the heuristic for it to come up with the better approximate is the following. You randomly initialize your means, run the whole algorithm, and come up with the error here. Then you do a random initialization again. Then you do a random initialization again. So run this algorithm several times and pick the one that is the minimum. The hope is, if one is going towards the local minimum, you may have chosen in several iterations, you may have chosen a starting point that is the best. So if you do more and more iterations, more and more iterations of the whole algorithm and pick the one which is the minimum, then the hope is you have better clustering.
No.
Make sense? This is the classic algorithm. It has a lot of advances. This algorithm can be made online. If the data is coming in a stream, you can make it online. There are online versions of it. They are very sophisticated dissimilarity measures. You can come up with those. And there are completely other algorithms that are that do the segmentation. But this one is the most popular, easy to convey, easy to understand, and most widely used as well. Yes.
अगर somehow जो दो मीन्स हमारे निकल रहे हैं वो दोनों एक ही पॉइंट पे आ जाते हैं
Yes.
तो इस पॉइंट पे क्या हम ये कंसीडर करेंगे कि हमारा ग्रुप ही एक था या हम ये कंसीडर करेंगे जो हमने रैंडम इनिशियलाइजेशन करवाई
So you have so random initialization is wrong. You never have to say कि हमारा ग्रुप बनता ही एक है. You somehow have to force every data point to become separated. मैं ये नहीं कह रहा कि दोनों ग्रुप्स बैलेंस होने चाहिए with respect to number of data points. अगर ऐसा है और आपको पता है कि इनिशियलाइजेशन पे डिपेंड कर रहा है, go and change your initialization. ये तो तब होता ना जब ये ग्लोबल मिनिमम की तरफ लेके जाता आपको in any case. तब आप कहते हैं कि यार एक ही ग्रुप है दूसरा ग्रुप बनता ही. अब ऐसा make sense? अच्छा इसको क्वेश्चन
सर यहाँ पे एक और डेटा पॉइंट आ गया तो दोनों U1 और U2 के साथ उसका डिस्टेंस फाइंड करेंगे फिर लेबर असाइन
Yes. So how a new point is assigned a group. So a new point comes in. So you assign the new point to group 1 if it is close to new 1, otherwise if it is close to new 2. And obviously the data standardization is a prerequisite. वो तो बताने की जरूरत नहीं है. Subtract the mean of the data, divide by the features, so the features become from -1 to 1. जब नया डेटा पॉइंट आए उसमें से mean निकालेंगे, उसको स्केल करेंगे, and then just apply the grouping. Make sense? There are several applications of clustering. आप ये सोच रहे होंगे कि how this clustering is used. कई दफा ऐसा होता है कि आपके पास
इसे भी फाइनली क्लासिफिकेशन की तरह सॉल्व करना जरूरी तो नहीं है
नहीं मैंने just example दिए कि distributed point. This is not a binary and then you extend it. No. It's like 4, 15 at the start.
बैठ का लेट्स हमने इसको 5 दफा रन किया और बस 5 मीन आ गए. अगर हम 5 मीन वेक्टर्स का दोबारा मीन लें और सर उसको एज अ मीन कंसीडर करके हम उसको क्लस्टरिंग करें तो बड़ी ठीक है ज़्यादा अच्छे रिजल्ट्स के लिए.
So computed the error. So you have an error here that you can once you have the grouping, compute the mean and you can compute the total error of the cluster. The error function की value, you can compute that. कर सकते हैं ना? हर मीन से उसके डेटा पॉइंट का डिस्टेंस लें और सारे डिस्टेंसेस को ऐड कर दें. That's the number, that's the total error. If in that way the error decreases, go with that. Otherwise, don't go with that. Because the algorithm does not guarantee the global minimum. Whatever heuristics you come up with, they may work, they may not work. I mean, make sense? और ये initialization भी करने के काफी सारे तरीके हैं. Initialization करने के sophisticated तरीके भी हैं. एक algorithm है K means plus. ये K means ही है with a better initialization. वो कहते हैं कि जब आप एक start में जब आप एक data point select कर लें as a mean, the second data point जो randomly select कर लें should not be very close to the first one. So select it far away, then select the third one that is far away from the two, and so on. So with this initialization, the rest of the story is K means. This algorithm is called K means plus. But even with that initialization, the local minimum value problem is still there. So the solution to the local minimum problem is run K means several times if you have time budget, and pick the one that's the best. And if your data has a clustering structure, if your data has a similarity structure in it, you will, the probability that you will find the exact clustering or the best clustering very quickly is high. Make sense? Now, let me comment a little on how can we use clustering as a help for classification. Because some people use clustering as a pre-processing for the supervisor. Even if they have the labels, they throw away the labels and segment the data, particularly in the images. And then they try to find out the labels. Let me show you that. Erase कर दूँ? समझ आ रही? ये तो बड़ा आसान था आपको लग समझ आ रही?
Kashif,
Yes.
the complexity of the algorithm.
This algorithm? Complexity of the algorithm is
Dependent upon the data, right? How they distribute it.
yes. This is actually this is reported as DK plus 1.
इसलिए मैं यहाँ से देर तक
N is the total number of data points.
D is the dimension.
B is the dimension and K is the total number of clusters.
So if so what is saying is that अगर D हमारी dimension 2 है और cluster for example मेरे 2 हैं, it will take n to the power 5 times.
Yes, if you, I mean in that case you can do it exactly.
एक बार बात सुनो, n to the power ये आप कह रहे हैं?
Well, this is not the complexity of this algorithm. This is heuristic based algorithm.
अच्छा.
If you fix the number of cluster A, and you fix the dimensions B, and if you fix both of these, then you can find out the global minimum of this one.
Then you can
Find
find
out the global minimum
global minimum.
in this time.
अच्छा, इससे बेहतर कोई नहीं होगा, यानी वो कम, you are
So
sure?
that's the global minimum, yes. The problem becomes.
But we haven't proved that, right?
We haven't proved that. We haven't proved that. The problem becomes tricky when either K is not known. I mean, you have to find out the total number of clusters also. I mean, एक तो यह है कि number of clusters supply करते हैं.
हाँ.
आप number of clusters भी खुद find out करें कि total number of clusters भी कितने होते हैं और ये error minimize, so then the problem is NP hard. If the total number of clusters are supplied and they are high, and you have high dimensional data, then using that algorithm that gives you global minimum is I mean, it's not feasible at all.
Yeah.
Makes sense? I mean, thousands of dimensions are common in machine learning data sets. So this is not the algorithm that we're using. So this is the one that most people use for pairs. I mean, although it is heuristic based, running 100 or 1000 iterations per loop around it is much faster than this one.
Because we just saw that last time जब necessary link कर रहे थे, totally unsupervised, उसमें तो हम n के n clusters पे लगा देते हैं, तो उससे half में ज़्यादा तो वो तो फिर क्या हो जाएगा?
So Ross, is that
n की power
नहीं.
d n बन जाएगा.
clearly?
नहीं.
Okay, so let me explain this. The actual problem is the following. What should be the number of clusters?
वो तो हम आगे बात.
Not given, let's say it is not given. And you want to find out the optimal number of clusters as well as the clustering error is minimum.
Done.
That problem is really hard.
Done.
Take it, not so to solve it in the time. Even we do not know whether it's empty computer or not, then we can't maybe away from it.
Yeah.
Second thing, if the total number of clusters if the total number of clusters A is given, then if your data has high dimensions, then the algorithm that will give you the global minimum has this complexity.
अच्छा.
Makes sense? That will give you global minimum. It is practically infeasible to apply that algorithm if your dimensions are high.
Yes.
So you use this algorithm, which is the approximate.
Even if the clusters are high.
Even if the clusters are high, and the number of data points are high. I mean all these factors are contributing and telling you whether you can cluster or not using the algorithm. And practically, people use this heuristic-based algorithm and run some iterations.
Some iteration बस है.
And normally they get. I mean, this is the practical way, and then normally they get better.
अच्छा ठीक है.
Best result. If the the last comment I made is, if the data has a segmentation or clustering structure, you will probably find out the clustering pattern very quickly.
Good.
Much quicker than this one.
अच्छा. और वो कोई approximation होती है? अगर few या वो
I mean, अगर synthetically आप देख सकते हैं I mean, you cannot compare it with whether it is approximation or not until you run this and compare the error with that.
Okay. So not theoretical, but practically.
Yes, it's okay if people go with that. If they want to use this segmentation in the subsequent steps, and this is a prerequisite, they don't even care. I mean, a lot of sensitivity in the pixel, and mostly this algorithm is used for images rather than the data that is. So the data, if the data has spatial structure, मैं थोड़ी देर बाद बताऊंगा, उसमें segmentation is most commonly used. Clustering is most commonly used as a prerequisite for classification.
No.
Make sense? So if the only goal is segmentation and that's $1 million problem, let's say, then you must have to focus on what algorithm I should use. If this is used as a prerequisite for some other task, then you may be focusing on that as well, and then this is just a prerequisite. Make sense? And the reason of introduction of this algorithm is because of a prerequisite in RBF networks. RBF networks uses k But this can be used as a standalone algorithm as well, whenever you want to use the segmentation. And let me give you one idea where it can be used as a segmentation. And that's a practical example I came up. That's a practical problem I faced 5 years back, and I tell you one solution with using clustering. Make sense?
So इसमें outliers की problem है.
करते हैं. Yes. So this is outlier sensitive. So that's a bad thing. And the representatives are not from the data. That is again a bad thing. So there are variants जो इससे बेहतर हैं. बेहतर in a sense कि there are other variants as well. Make sense? Let me just show you one example, and you will appreciate that clustering sometimes has been classification as well. Six or 7 years ago, I was working on satellite image classification, particularly for village farmers and in lines, village farmers. So I was working on that problem, and let me show you that problem. Let me describe that problem to you and one solution which involves clustering. What I really did was village finder करता है कि you have large images and you actually classify each pixel of the image, whether that pixel is a village pixel or a non-village pixel. Village pixel और non-village pixel. तो होता ये था कि और हर पिक्सल की हमने कोई फीचर for each pixel हमने कोई फीचर वेक्टर कंप्यूट किया for every pixel, not for every image, for every pixel of the image. Each pixel is a data point, उसका कोई फीचर वेक्टर कंप्यूट किया था और हर फीचर वेक्टर क्लासिफाई होता था in one of the two classes, whether it is a village pixel or non-village pixel. Make sense? अगर जब हम ये लाइव क्लासिफिकेशन करते थे ना, तो होता ये था कि फॉर एग्जांपल ये काफी सारे पिक्सल्स हैं जो विलेज पिक्सल्स हैं, बीच में कुछ पिक्सल्स आते थे नॉन विलेज पिक्सल्स। अच्छा। और इसी तरह से काफी सारे ये एरिया था जो नॉन विलेज था, बीच में कुछ आ जाते थे कि ये विलेज पिक्सल्स हैं। दिस इज हाईली अनलाइकली कि ऐसा हो। ये बात समझ में आई कि यार एक विलेज है तो कंटिन्यूअसली एक विलेज होगा, लेकिन चूंकि हम पिक्सल बेस्ड क्लासिफिकेशन कर रहे थे एट दैट टाइम, पिक्सल बेस्ड क्लासिफिकेशन हो ही रहा था कि हर पिक्सल जिस पिक्सल पे एरर हो जाता था वो अगर विलेज के अंदर पिक्सल आ रहा था तो नॉन विलेज है। Make sense? So what we did at that time, is that we took all these points and we clustered them based on their similarity. Make sense? So let's say this is one cluster and this is another cluster. And now we keep on, classifying all the data points. If in this cluster, a very few points are classified as, we say that's a classification error and we weight clustering higher. And we say this is a village error. Classifier is making an error because of pre-clustering. You got some Yaki? Yes, no? Yes, no? इसी तरह से सो ये पिक्सल बेस इसमें ये एक और चीज इमेज के अंदर ये बहुत बड़ी इमेज है, इसके अंदर अगर आपने पर्सन ढूंढना हो कि किधर है, तो एक तो ये है कि आप हर विंडो पे जाके पर्सन लगाएं, दूसरा ये है कि आप इस इमेज को सेगमेंट करें इनटू सेवन. दिस इज हाईली लाइकली कि ये जो पर्सन होगा इट विल बिकम इन वन सेगमेंट and then classify each segment that will improve your sliding window performance. So there are a lot of variants, there are a lot of applications of clustering in classification as well, and it can be used as a standalone algorithm as well. Make sense? Okay, next time I will discuss inshallah RBF networks. That's a classifier that uses the k-means clustering.